So we are back in to go more in depth for clash detection. And so the previous video or session, we exported the clashes that we have, and we are now simulating that we have sent these clash reports to the subcontractors, and they have came back a week later and they have mentioned to us that, you know what, we have fixed these issues based on your clash report, and that's what we are simulating. So they have updated the model and have given us a new model. Okay, so I need to go to folder number 3, and under the MEP folder, just double click on it. You will see in the cache file and the file set file, okay, and inside you will see two other folders, original and updated NWC. Okay, so again, we are simulating that the MEP guys have came back with updated model. So open up this updated NWC. Okay, copy this file here. Oops. Wait a minute. Okay, I have issue with this. Anyway, after you copy, go back one step, and this is the existing, the old one. So just right click and override this, replace the file. Okay, so what we are simulating right now, MEP guys saw the report, they have fixed the issue, they come back 1 week later and tell us that they have updated the model. Okay, so going back to Navisworks, go ahead and press the refresh button. Okay, remember when you have updated model, then you need to refresh, right? So that's what we're doing. And kind of messy here, but don't worry about it too much. Okay, just look at test number 1. You will see an exclamation mark, yellow in color, that appears after you click on the refresh button. And the reason why is because when there's new changes, you need to rerun the test. So the exclamation bar is telling you that your current results, there's 8 clashes. These are not updated yet. Okay, you need to rerun it. So to rerun the test, just right click and run again. And you can see it's no longer red in color, right? Okay, can you see it's all yellow, and the status is resolved. Okay, so it means that they are right. They have these MEP subcontractors have kind of fixed all the issues that we showed them in the clash report, and that's great. And if you want to, look around it, okay, just spend some time to maneuver around. Oops, here. Okay, just go and see if there's clashes. There's probably no more clashes in the model itself. Okay, you can see they are close to each other, but they no longer clash as before. Okay, so when they no longer clash, okay, one of the behavior that you can see over here, just because it doesn't clash anymore doesn't mean it's not going to show up. It's going to show up as a resolve. It's not going to be blank. It's not going to be an empty clash report. It's going to show that you have these 8 resolved clashes. Okay, so once you have your updated federated clash test, okay, what you can do is you might want to create a report again, just to keep a backlog that the guys have changed the model or have resolved issues, the conflicts in the model. Because there's one button next I'm going to teach you is this button called compact, meaning that you can see over this button here, it says clear resolved clashes from this test. The moment you press this button, these clashes that are resolved will not appear on this list anymore, which also means that if you wanted to do a report that showcase that that the people has been fixing the issues, you no longer are able to do that. So if you need a report to let different parties know that the issue is resolved, I kind of recommend you to write a report here. Okay, so I'm not going to do that, but just in case you need. Okay, so go back to the results. You can use this compact. Okay, and anything that's resolved will no longer show up in this list anymore. And you will never get it back unless you go and revert back to the old MEP model, which is a hassle, right? So if you need a report, go report first. Otherwise, if you feel that you don't need a report for resolving of clash, just use this button, compact, so you no longer see them again. Okay, and let me see what else we have here. And yeah, we can basically save this file and close it. Remember, close is the new button. In the next video, we'll be still doing clash detection. I believe we have some time. So what we can do here is go to folder number 4. I need you to go to folder number 4. Oops, folder 4. Okay, so folder number 4 has a few files, and I need you to open the first file, 01 clashes, the Navisworks cache file. Go ahead with that. And once you open the Navisworks cache file, you can see 4 pipes. Okay, just rotate around, you should be able to see 4 pipes. And I want you to go to viewpoint. Sorry, is it viewpoint? Yeah, viewpoint. Change the mode to be wireframe. Okay, and I have a task that I need you to do at this point in time. Is let's take a look at the pipes. They are of different sizes. Okay, one big and one small one here. I want you to kind of rotate and orientate yourself in such a way that you kind of figure out whether these two objects here are touching each other. Okay, so right now we are going to use the clash detection to prove that there's actually no clash. Okay, we're going to use the clash detection tool to do that. Add test, and this time I want you to select there's no sets created in this file. So click on the large pipe and use this button called use current selection. And you can see this is the third pipe. There are 4 pipes in total in this file. This is the third one. Now click on the smaller pipe and use the same button, use current selection, except that you will be on selection B here. Okay, so this one here is the 4th pipe. Okay, it doesn't really matter between the 3rd and 4th pipe. I'm just telling you that they have each object belongs to one of these items in the list. Okay, just make sure this is hard and tolerance 0.001, and we go run test, and there is no result, which means there is no clash. And it also means that we kind of confirm there is actually no clash between these two objects at this point in time. So right now I want you to do is to click on this Navisworks icon, options. Okay, file readers. Click on the plus icon, go to Revit, and you'll see these settings called factor. I want you to change it from 1. It should be 1. Okay, at this point in time your computer should show 1. I want you to change to 50. Press the OK button, and you will realize that nothing actually changed. Okay, but I'm going to take a snapshot of the current view that we have. So this is how it looks like currently, and I want you to click on the refresh button. Okay, so when you change the factor, you need to click on the refresh to see changes. So what does the factor actually do? You probably get a clear idea once it kind of loads, and you can see when you increase the factor, there are more lines drawn. Right? It looks more completely rounded. Okay, so after you change this, the factor itself, okay, I want you to run the test again. Right click, press run, and now you will see clash number 1 appearing between these two objects. So why, when the factor is increased, there's a clash? Okay, so this is one of the reasons why. Let's say if you are running a clash test between all the models, and the other party, maybe you're the contractor, the consultant themselves decided to do their own clash test. Your clash has maybe 100 clashes identified, and then they come to you and say, you know what, we run with the same BIM models, we have 300 clashes. Why same BIM model but a different outcome? Okay, one of the reasons why is because you haven't agreed on this number here, the factor itself. So before you run clash detection, just make sure that all parties agree to use the same factor. Otherwise, if multiple parties are running the clash detection, everybody will have kind of different results, and partly due to this factor here. And of course, the higher you increase this number, then it kinds of the geometry of the elements becomes more defined and more accurate. You can see it's more as a rounded circle. But at the same time, you will find more clashes as you increase this number. So most of the time what I suggest is to keep it the lowest. The lowest you can input is 1. And the reason why I recommend putting it as the lowest is because if you're going to set it to be super accurate in terms of geometry, you will find many clashes that does not impact the cost and time of the project. Meaning that even though these two objects might be colliding in the BIM model, there will be no issues during the construction. This can be rectified immediately on site. There is no need to point it out as a clash and then to go through the hassle of saying, nah, this is not something that needs to be solved in the BIM model. We can solve it on site. So you may have 100 to 500 over items to 1,000 items that, you know what, you could have just solved it on site, but since you use a higher factor, they kind of appear in your clash list that you need to filter them out individually, which is a hassle. Okay, so I always keep it as 1, and if there's clashes that are so minuscule over here, then it's better to solve it on site. There is no implications to cost, there's no implication to time as well. In fact, when we increase the factor, we would in return encounter cost and time overruns. Okay, so keep it as 1, press the OK button, and remember when you change the factor, you need to press the refresh button.